Hot chocolate, Azure Cosmos, Dapper. Entity Framework, Power Tools, Technology Suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Likeness.
Shay Rojansky.
Grace Lanston.
Arthur Vickers.
.NET Data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Stand-Up.
Hey everyone, welcome to the final .NET Data Community Stand-Up of the year. This year's been all about EF Core 7 and .NET 7, and for the final stand-up of the year, we're going to show you what we have in the plan for next year for EF Core 8 and other work that we're doing around .NET Data in the .NET 8 timeframe. So I'm here with Shay and Json. Json, I think, is going to, play the part of the newbie on some of these questions, which will be cool. Why are you doing that?
Totally.
What are we doing here?
Playing the part of the newbie that I am. I'll be here to ask all the annoying clarifying questions.
Exactly. Yeah. Sometimes we assume people know too much, and we just go way ahead. We're going to hopefully do a few next year stand-ups and videos and stuff on just getting started as well. But anyway, okay. So for the last time this year, let's do State of the Unicorn. There's not much on here really. EF7. Wow, this is really small. I should have made that bigger. But anyway.
But the number is really big.
Million NuGet downloads. We released about 5 weeks ago, like 5 weeks and 2 days or something like that. And it was already 1 million NuGet downloads of EF Core 7. So jump into that if you haven't already. Remember, it runs on .NET 6. So even if you're tied to an LTS platform, you can potentially still use EF7, which isn't LTS, but runs on the LTS platform. Okay, and then as always, we have a big What's New section with lots of information about all of the changes that we've made and runnable samples. You can download the samples on GitHub, run them all, debug into them, look at what's going on. aks.ms efcore what's new to find that stuff. And now we're looking forward to EF8. So that's what we're going to talk about today, the plan for Entity Framework Core 8. And indeed, that plan is published on our doc site. And there's also a short link for it there, aka.ms EF8 plan. So easy to find. And let me actually bring it up so we can start talking about it. I've got to find I've got to find it now. Too many windows
good.
open
I was going to
here.
say, what a beautiful plan.
Oh yeah, well that's Bing, right? You know, Bing. You get Bing wallpaper, and you get these beautiful wallpapers every day. It's
Right.
you know, it's really really makes my life better, I think. Okay, so that's actually not that's the GitHub issue where you can go and comment. We've already got some comments from Eric there on issue on the plan, and the actual plan is on our docs site, which is here. A nice logo, thanks to Bryce for doing that. So there's a bunch of themes here which we're going to go through, but before we get too far into that, I want to just say that when it comes to the cloud native and devices, which where we're looking at some AOT ahead of time compilation stuff for EF Core and data in general, Shay has been working on prototyping some of that stuff, and he has a really cool teaser demo where taking a link query and having it pre-generate code to run that query that then gets compiled ahead of time. So it's not really at this point ahead of time in the sense that it's doing all of the compilation,
Don't tell
like
everything,
the
Arthur.
JIT stuff. But what's that?
Yeah.
No
Don't tell everything.
spoilers.
He's
Okay,
Don't spoil the
spilling the
plot
beans.
twist.
But it is
Yeah.
moving towards that direction, and it's a very cool demo. We're going to do that nearer the end, so make
Which
sure
means you
stick
guys
around
have
for
to
that.
stay. Exactly.
You have to stay around for that. Yes.
Yeah.
I'm losing everything here. I've lost you guys now. Let's see. Where is? Oh, it must be. No, that's not it. That's YouTube. I've got to get you back, otherwise it's going to be. Oh, okay, I've got you back. Otherwise it's going to be really confusing for me. Okay. So let's talk about some of this stuff. Okay, boring stuff first. Currently, okay, even boringer stuff. There is no EF Core 7.1. There will not be a 7.1. There's no 7.1 planned. The next version after 7 is 8. You should be used to this by now, but just saying that. So if you're looking for something saying, can we go in 7.1? No, next one is 8. It's going to be released next year in November. We have this standard cadence releases now. Same time as .NET 8 will be released. It's going to be an LTS support, long-term support, so 3 years of support on this. We alternate LTS with short-term support, and again, that's the same as .NET 8. It will probably target .NET 8. Ideally, we would keep it on .NET 6, but it's likely that we will need to take advantage of some of the benefits, some of the new features in .NET 8, and therefore, given that .NET 8 is also an LTS, we will probably end up targeting .NET 8. I think for a long time, though, for as long as we can, we'll keep targeting .NET 6 to make it easier to use the previews and the daily builds and everything without having to update your platform. And maybe at the end of it, we'll say, oh, actually, we'll just stay on .NET 6, so it's not fully decided yet. Doesn't target any .NET Standard versions. If you're still, thinking about .NET Standard, then read this great post by why am I blanking on his name? Come on. Anyway, I'll have to click on it and then I'll remember his name.
The time for .NET
Immo.
Standard has passed.
Yeah, why am I forgetting? I'm sorry,
There we
Immo.
go.
I just forgot your name. Yeah, great post on Immo about why there is no future for .NET Standard. And of course, it will not run on .NET Framework. Yeah, this is painful for some people, but unfortunately, that's just the way it is. There probably will be a few breaking changes. We try not to make too many breaking changes. We certainly have got less and less as the releases go on. At the same time, we can't get into a place where the .NET Framework was, where everything stagnates and can never change at all. So we do carefully look at breaking changes and say, okay, in this case, it makes sense to break for the future of the platform rather than not. But we take them all very seriously.
Mm-hmm. And I mean, even clicking through that link, it's like, here's the list of all the potential breaking changes, and it's like
yes,
an empty list. So I'm sure it'll get added to, but please know, yes, it's not possible to make an omelet without breaking a few eggs, but if we don't have to
Yes.
break those eggs, then ideal.
Absolutely. And so you can see, like in 7, we only had like 8 breaking changes here, which is and most of these are kind of low priority, and some of them were out of our control, so not too bad. We did, like, if you go back a little while, I don't know if I should show this or not, but where's the releases and planning? Here it is. Let's go back to the out of support, like 3.0, breaking changes. Yeah, that was quite a lot more. So we're breaking less as we get more mature, which is kind of what you'd expect, I think.
Mm-hmm.
Okay, so we've kind of tried to create a cohesive plan by putting some themes, putting some themes around what we're doing, and making sure that we have a good story that resonates at the end of it. But there's a lot of overlap between these themes; they're not exclusive. As always, we look at your votes for issues on GitHub, and we try and work on highly requested features. So your votes matter. Make sure you thumbs up the things that you care about. So that's one theme. We're also looking more and more at cloud native and devices, which really means using EF in kind of a microservices environment or on a mobile device, kind of outside of the scope of a traditional kind of monolithic web application, which is the main place where people have used EF in the past. We always want to do some performance work, and we're going to look at SQL Server driver for that, which we'll get to in a minute. We're actually going to have Bryce go off and do some work in Visual Studio. So that's kind of a change from what we normally just focus on the runtime, but we feel like we really need to make a little bit of add a little bit better support for some areas in Visual Studio there. And then we have a lot of kind of smaller things that just add to improving the developer experience. So this is, rounding out a feature, adding a small enhancement, making the general experience for using EF Core better, basically. Okay, so let's start. Let's go through and look at highly requested features that we're going to work on. These are actually quite familiar to everybody, probably, because we've really carried these over. We over-committed in the last release, and we weren't able to do everything that we wanted to do. And we also expanded the scope of the Json feature significantly. Go look at some of the stand-ups and the web and the what's new and blog posts and things on that to understand what we did there. But it's a significantly more powerful feature than we had originally anticipated. And as such, we got the basics of that in, but there's some stuff that we didn't manage to fully complete, and so we're coming back to this in 7, and Maurice is going to spend time kind of really fleshing this out. Go ahead.
Can I ask a basic question? I'm seeing on the value proposition about how, the purpose of JSON columns is to power that document and relational hybrid pattern. I just, I was kind of curious about, like, what are the benefits that come from building on that pattern, about making that hybrid?
Great question.
Yeah, great question. So, there's document databases like Cosmos DB out there, which basically store your data as documents. So, each piece of data, if you like, has a root document, which has some sub-documents inside it, and you end up with, this document structure. And that's a very kind of intuitive and flexible way to store a lot of data. It's quite easy to handle. It maps often to what the way you read the data and use the data and manipulate the data. And of course, there are standard relational databases where you split everything out and you store everything in columns and rows, and to a large degree you normalize it and you put relationships between the two things, and then when you want to bring stuff back, you bring all that in and you reconstruct it into whatever it is that you're actually going to display to the user. And both of you can do pretty much anything with both of those, but some scenarios are more suited to documents and some scenarios are more suited to the relational model. With JSON columns, that you essentially get the ability to embed documents in your relational database. So while you can say, okay, most of my data, the data I want fits very nicely to a relational model. So maybe I've got a big product catalog, for example, there's parts that you have to order, there's customers, and all of that has to, come together in different ways when you're doing different parts of your business goals. You might also have, for example, addresses or contact information or a set of reviews or something like that, which are inherently documents. So instead of those things necessarily having to split them out to go into different columns and across different tables, you can now have a column in your relational database where you store the documents. And so you get this advantage of where it makes sense having documents in your database and where it makes, but still having a relational database for the rest of the stuff. And so that's the idea around this JSON column mapping. And I think that's why all the major databases have support for JSON columns now as well. Shay?
Yeah, I'll add two small things in addition to your excellent overview. Imagine like a very simple example. Imagine you want to stick like a bunch of tags or a bunch of numbers on something, right? Like a list of numbers, right? In a relational, like a traditional relational database, that is actually non-trivial. It's not easy to do this, and you can have another table and start joining, but that's complicated. It's going to be possibly also slow. And if you just want to stick, an array of numbers, then you can just do a JSON array, like basically a document of those numbers, and you're done. It's very, very simple. It's part of your table. It's super simple, right? So there's many. That's like a no-brainer, very, very kind of dumbed down scenario. But I would say in general, like in scenarios where you have a very deep hierarchy, right? You have like this contains that, contains this, contains that, like a very kind of deep thing. So in a relational database, you have to model that through tables, and then you have to join those tables. So it's complicated to model a little bit, like conceptually, and it's also maybe not as performant because you have to join all these things together. And there's various problems. There's the Cartesian problem when you're going to do like all the one-to-many. Anyway, all these traditional problems of relational databases. If you model it as a simple document, like this big hierarchy, it's simple, it's easy, and it's probably going to be performant. It obviously has some disadvantages as well, right? Relational databases do certain things extremely well, and that's why they've been so successful, which is why I think in 2022, 10 years ago, I remember this, there was the whole NoSQL movement, and people were saying, SQL is dead and relational databases are evil, they're slow, they can't scale. I think, we've all matured, the world has kind of matured, and we know now that it doesn't, NoSQL databases, document databases now have more guarantees and more consistency guarantees and asset even guarantees in some cases, which is more a relational traditional thing, whereas relational databases now have stuff like JSON columns. So the two worlds have kind of, a little bit converged compared to the way it was like 10, 15 years ago, right?
Yeah, exactly.
Got it. That makes a lot of sense. And I guess it speaks to EF8's kind of overall commitment to providing for a whole bunch of different things that people want to do, right? It's not like, hey, if you want A or B, then you're good to go. If you want C, well, you're out of luck.
Yeah.
And I have a follow-up. Yes, please go ahead.
No, I mean, we had this. I know I wasn't on the team at that point, but when EF Core started, as opposed to the old EF6, for example, EF6 was an ORM, an object relational mapper, right? And it supported relational databases, whereas EF Core was built from the ground up to not just be that. It's actually a more general thing that you can use to also access other types of databases like Cosmos, like NoSQL databases. So it was conceived very much with this in mind. Now, JSON columns are a bit of a different case. It's more of a thing where you integrate, a document concept into a relational database. So it is part of the SQL Server, support. But all these things are very connected. Basically.
Yeah, and if you look at the way EF supports Cosmos DB as a document database, and you look at the way we now have JSON columns, there's a lot of similarity between those things. The concepts that you use in Cosmos also apply to JSON columns in a relational database, and so that's why I like to refer to it as a hybrid between the two. It's like you're getting, if you use it correctly, because you can always use these things wrong and put the wrong data in the wrong format, but if you use it correctly, you get the power of your relational database while still being able to store documents without having a dedicated document store that is really, then has to somehow also integrate its, those values into the other things, and Polyglot is a great kind of mantra for, I store it in the way it makes sense. But when you can have that all integrated into your database system, it makes it a whole lot easier. Okay, some of the things we're
Not to
going to do on
be.
JSON columns. Sorry, go ahead.
Oh yeah, sorry. Yeah, like one other question, which is kind of building up what you were saying about, now from the start, EF has been about having support for a broad variety of databases. And I'm seeing here in JSON columns that you kind of single out SQL Lite as one piece that you want to have more support for. And, I know a little bit about SQLite. I've heard that it's like a database that's not a database, kind of. It's like really lightweight. But I was curious about, what is, like, kind of what's the range of, like, just broadly, like, what are all the, like, cool things that people can do with EF because there's so many, like, databases that it provides
Yeah,
for?
so that's another interesting question. So we've already talked about Cosmos being a document database, and something like SQL Server or Postgres being traditional relational databases. And by traditional, what I mean is there's a database server running. So somewhere there's a server that's storing your database that you connect to, you run queries against it, and the data comes back. SQL Lite gives you another possibility, which is, so SQL Lite, there's no database server. It's just basically an in-process set of code that accesses a file and makes that presents that file to you as a relational database, essentially. And it still has a lot of the advantages of a relational database in that you can put indexes on things and you can create relations, and you can have constraints and all of that kind of stuff. But it doesn't have this overhead of having to run a database server that then supplies all the data. It just basically accesses a file, and so it's very lightweight, hence SQLite. And this makes it perfect for example, running on a device. So if you've got a mobile phone and you've got some local data that your application is using there, then put it in a SQLite database on the phone, and every phone that you have, any phone that you can get, has SQLite already on it, by the way. Put it in a SQLite database, and now you can access it with SQL queries. You can, like I said, you can index it, you can get the performance, you can do all of these things that you could do with a proper database, if you like, but it's still on your phone and you're just accessing a file. And so it's very powerful for those cases, and it's powerful specifically because it's more lightweight. So it's like an example of where you build something very specifically to be lightweight, and that really makes it a powerful solution. And it seriously is everywhere. Windows ships with it. It's on every Linux distribution that you can think of. It's on any mobile phone that you have. It's probably in my washing machine, as far as I know. That's probably going a bit far. I don't know the washing machine really needs to keep any data necessarily, but it goes everywhere, works with everything, and it has some limitations, but they're not as many as you would think.
And don't we all have some limitations?
Exactly, and in terms of its database capabilities, it can do a pretty good job, and there's extensions to it that can also allow it to do other things like spatial services and things like that. So the fact that you've got EF going to all of these things means that you can use it in a lot of these different places, which is one of the reasons why we care about mobile devices, and that's one of our themes here, cloud and mobile. And I think if you haven't seen Steve Sanderson's demo where he runs SQLite with EF in WebAssembly, so in your browser WebAssembly, all of that is just running there on the client. That's a compelling case for using SQLite. And it's a great example of EF and .NET allowing you to have like a very consistent and usable access to it.
Yeah, that makes a lot of sense. And I guess what I'm saying is just, as a newer dev, like, I know that it's important for me to be able to start pretty light and be able to kind of scale up to more complex situations without having to switch gears completely. So not
Yeah.
to be quoting Hannah Montana on the stand-up, but it really sounds like the best of both worlds, where like you have
I'm
such a
not
low
up
barrier
on my
to
Hannah
entry, but
Montana quotes, but yes, great.
no, all right. All right, that's it from me for
Okay.
now, though.
Okay, so yeah, SQL Lite support, JSON columns in SQL Lite is one of the things we want to do. Some better support for collections, being able to use your own custom serialization, being able to configure do better configuring of the columns that are actually used, max length and things like that. So some of these things that we're planning. Also, make sure though you go and vote for your favorite SQL Lite. Not SQL Lite, JSON stuff. There's a label on there, like area JSON. If you look for all issues in area JSON, you'll find anything. Don't just go vote for everything. Actually, give us some useful information about which ones you really need, because that'd be very helpful. Okay, value objects deferred for a couple of releases now. Shall we look at some code on this one? Let's look at some code real quick.
Let's have fun.
Okay, so I'm going to talk a little bit about why we need value object support and why own types are not cutting it, because own types were intended to be value object support, and they really don't work that way. And on the team, we've kind of decided to stop trying to force a square peg into a round hole and instead, try and add better support. So I'm going to try and it's a bit nuanced, but I'm going to try and show some of the issues with this. Okay, so we're going to start with something very simple. I've got a person, entity, and it's got a name property. I've also got this random name thing that we'll look at later, but for the moment, just concentrate on a person with a name property. So I can add a bunch of people to the database. Some of them might have the same name, some of them have different names, save them, and then read them back, right? So, I'm going to say the thing that I always say. This is all simple stuff that you should obviously know how all this works and just be obvious, right? Anyway, so hopefully it isn't that difficult. Okay, so let's do a couple of things with that. They'll be really kind of obvious to start with, which is kind of the idea. So I'm going to query back the people, and I'm going to say, okay, let's change the name on one. So let me set one of the person's one's name to person's two's name. So in this case, it's going to change John Smith to David Jones. So this one to that one. And when we run that, we should find that it does what we expect. The last thing it should be a update in the database that makes that change. And indeed, we do indeed have that here. So you can say we're changing it to that one to David Jones. So as you would expect. Now we could also do something that might seem silly even. Let's say instead of doing that, we'll actually just change John Smith to John Smith. So we're taking the name off one entity and putting it on the other entity, but they're actually the same name, right? So ideally we wouldn't do anything, right? Because we're not making actually any change to the data. And you can see what happens is, in fact, the last thing that happens is that query. We never, even though we called save changes, nothing went to the database because we didn't change anything. So that is also what you'd expect. And then we can also, imagine our like name database. Our boss has told us, okay, get rid of everybody's names. GDPR, we can't be having that. And so we're going to set everybody's name to anonymous. So we can say, okay, let's anonymous. That's what we want. Let's loop through all the people, set them all to anonymous, and save. And again, it should basically do what we expect, right? We end up with an update at the end of that, and it's setting each of them to anonymous as we expect. Okay, so all that's fine. But what happens if we now say a boss comes to us again and is like, it's really hard to know what people's first names and last names. And you say to your boss, not everybody has a first and a last name. That's a very Western centered view of everything. And he says, I don't care, go do it anyway. So then you're like, okay, right, we can do that. Let's create a type for name instead of just using a string. and I've got a class for that here. Got a class for that. So it's a name, has first name and last name, and a couple of properties. So pretty straightforward. And then in my entity types, I'm going to say, okay, well, then let's change this name to name. So we're going to use my name class. And obviously now I have to initialize them differently because now I need to actually construct name instances. So let's do that. But pretty much now everything looks very similar. But if I run this, it's going to throw an exception because it's going to tell me, well, this looks like an entity type, but there's no primary key for that. Like, I can't figure out what the primary key is. And it's like, okay, well, you know what? Own types don't need primary keys, right? So we'll make this an own type, and then hopefully it's going to act a bit like, for those of you who know it, a DDD value object, right? This is like, it hasn't got any identity. A name is just its first name and last name. If it's John Smith, it's John Smith, it's John Smith. There's no, like it was on the string, there's nothing that says like one John Smith is different to another John Smith. That's what the person is for. The person with what name John Smith is different from another person with name John Smith. But the name itself, and I said this was a bit nuanced, the name itself is the same regardless, right? This is the idea of a DDD value object. Okay, so we've got that, and we should actually be able to run that, and it will save it to the database, and everything's fine. So indeed, it's saved first name and last name as 2 columns in the database, and that's all fine. Okay, but let's try and do some of these things that seem just trivially simple before. So I'm going to take the name of one person and put it onto the next person. So what's going to happen here? Well, let's try it and see what happens. It throws an exception. Well, why is it shouldn't throw an exception? And it gives you this actually quite bizarre, if you don't know what's going on, message. It says, person name person ID is part of a key and cannot be modified or marked as modified. And then it gives you a whole bunch of stuff. So why is it doing that? Well, it's because this is now mapped as an entity type. And so EF has created a key for it behind the scenes. When it queries it out of the database, it puts that key into a shadow property. And when I go and do this, what I'm essentially saying is take this entity type and put it onto this entity type. Take this entity instance and put it onto this entity instance here. But because it's an own type, it's supposed to have the same key as the owner, but it doesn't because it's already a different instance. And what's more, I haven't removed this one, so now I have 2 owner entities pointing to the same instance of an own type, and it doesn't work. So could we try and make this work? Yes, we could try and like special case this to say, okay, in this case, let's change the key. Let's try and clone the object or something so that we don't have 2 objects, or let's make it so that you can share that object and everything. But fundamentally, this is not working like we would expect it to do if it was a value object. And likewise, if we were to do this, we'd have the same issue. Even though these are conceptually the same name, it's still going to say this name belongs to this entity and that name belongs to the other entity, and you can't replace one with the other. So that is kind of fundamentally, and I could show this example too. Again, here you're going to get a different error. So in this case, you're not. Oh, we need that to be a name. So let's kind of do new name, and then we need a first name and last name because we've become Western centric. So okay, boss wanted it, so we'll have Anony Mouse, our favorite person. Right. So now I'm not taking it from one entity to the other entity, right? So I shouldn't have this key problem that I had before. But what I'm actually doing here is I'm assigning the same instance to many entity types. So again, if I run this, it is not going to work. I hope I'm not losing everybody on this or proving how bad EF is. So what do we get here? An error occurred. Trying to find the actual message. Oh, yeah, and I don't understand why it gives you cannot insert null value. That's really weird. But anyway, it's because it's trying to share the type. How can we deal with this? Well, we can tell EF, don't treat this as an unknown type. Treat it just like you would treat a string property. The string property worked fine. Can you not treat our name class like you could a string property? And the answer is, fortunately, yes, you can, and it's easy. So let's go to our context here. What we need to do is write a value converter for it. So I've got some code pre-written here, and my value converter is trivially bad, but it does the job. And that will demonstrate one of the issues that we have here. So my value converter says, okay, take a name and convert it to a string. So store it in the database as a string. And when you're when you're going to the database, you do that just by taking the first name, putting a space, and taking the last name. And when it comes back, you split it on the space to get the first and last name. Now, obviously, if there's a space in somebody's first name, this is all going to break down and work. So you could serialize this JSON and do all those things, right? We're going to come back to this in a minute because there's an obvious thing about this, which is why we want to work on this in EF8. But I want to show that once you've got a value converter, and also I'm using configure convention to say anytime you see a property of type name, use this conversion. And this will say, don't treat names as entity types anymore. Name is not an entity type. Treat name like a string or like any other type. It's just a value. It's just a value in your entity. Okay. So if we go back to our code here now, so now let's try and do some of these things that we did before. So now I can say, okay, if I want to change John Smith to David Jones, it works again. It works exactly like we thought it should. David Jones is now being saved instead of John Smith. So it worked exactly like we thought it should before. Likewise, I could go and do this thing where I'm saying change John Smith to John Smith. Now, what's going to happen in this case? This one is kind of interesting. Ideally, remember, when we use strings, it did nothing. Why is it not do nothing here? It's even though it's already John Smith, it's changing it to John Smith. Well, that comes back to our definition of the name class. So our name class it's a class. It's a reference type in C#. And that means by default, it's going to do reference semantics. So if you have one instance of name, it will be considered different from another instance of name, regardless of what values it have. If they're different, then if they're different instances, they're different. And so when EF is looking if these have changed, all it can see is, oh, this is a different instance from that. So I'm going to save it because it's different. There's several ways you can deal with this. You can use what's called a value comparer in EF. So if you've already got this name type defined, you don't have to change it. But if you have it, one of the best ways to deal with this is to go and just implement equality. So I'm going to implement equality using first name and last name. So this is just standard patterns that you get. So I've got an equals method and it's done hash code for me. As we know, if you do equals, you have to do hash code. Okay, so now if I run this again, because it's got that equality semantics built into the object, now we see it correctly doesn't update anything. It knows that because this name here is John Smith and that name is also John Smith, no change. I don't need to save anything. So again, we've kind of got back to where we were. I was gonna, for the sake of time, I won't go completely into this example. However, I will say this. Rather than doing this semantics, and rather than keeping this as mutable, when you are using value objects like this, it's much better to just make them immutable. Because if I now have, for example, up here, I have the same object. In this case here, right, I have the same object being used by two different entities. And down here, because I'm putting the same object on multiple entities, if I now mutate the name for one person, if that object is also reference from other people, their name will change as well. And that's generally not what you want. And this is why string in Java and .NET and a lot of other places are implemented as immutable objects. Like you can't change the value of the string instance. When you do, string A plus string B to concat them together, you get a new string. You don't ever change, those instances. If you want to do that in C#, you can get rid of all this. Actually, you don't need any of this comparison stuff anymore, and we could just say make this a read-only. Doesn't have to be read-only, but we're going to anyway. A read-only struct, so a value type, and we're going to say, okay, get rid of that. So now this is I've got a class in there still. So now this is a read-only struct basically. And it will still work in all the correct ways. And in fact, let's just run this one here to show that when we don't change it, it detects that nothing has changed. EF knows how to basically compare simple structs such that it won't recognize a change if the members of the struct have not changed. Okay, so that's hopefully gives you some idea of why you want to use regular properties as value objects and not use own types, which are really part of an aggregate and are still entity types and still have IDs and still must be classes and have an identity that's based on that instance, why you don't want to use those for value objects. But let's go and look back at our value converter again. In this case, we had to write a value converter that took our two properties in our value type and merged them together into something in the database. So often that would be a string. So you might use JSON serialization for this or whatever. The point is it always goes to one column. What we really want to be able to do in EF Core 8 is for you to still be able to map this to a first name column and a last name column in the database, which avoids all of these issues of trying to make sure it serializes and what happens if the name has a space and you've done something naive like this and then it doesn't work. Just have a first name and a last name column in the database, which is what you would get if you used an own type, but still have it have these semantics that you get of treating it just like a property with a value converter. And that is what this feature is all about. Okay, I'm going to stop talking now, as Shay has been like typing away. So I'm going to ask Shay, does it make more sense to you why we want to do this now?
I have my thoughts on this. I understand the problem, but it's a complicated thing. We definitely have a lot to think about.
That's a diplomatic way of saying no. We still should be doing it some other way. But anyway. Okay.
Like I think it's not easy to give a one-liner about when should I do it like this, when should I do it like that. I think it's complicated, and I mean, yeah, I don't know. We'll see.
Yep. Okay. So should we keep going then?
Sounds good to me.
Okay. So SQL queries for unmapped types. So we partially did this in EF7. So now if you've got a simple scalar type like int, string, whatever, you can write a SQL query, a raw SQL query for those things, and EF will give you back the results. What we don't have yet is a composite type, so a class, for example, address with street, city, zip code, and country in it, and that's not in my model, so I haven't defined an entity type for it. If you haven't defined an entity type for it, then you can't write a raw SQL query that will return that type. You can map it as an entity type, and it doesn't have to have a key. It can be a keyless entity type, and then you can return it. So that's one workaround for not having this feature. You can also use something like Dapper, or just write a raw AGO.NET query to do it. So that's another, that's another way of doing this, which I think Shay believes that we shouldn't spend time on this, and if people want to do this, they should just use Dapper with EF Core, which is a valid position, I think. But we also know, well, I guess we know that some people are not comfortable with doing that. But also in my mind, just having to pull in Dapper as an additional dependency just so that you can easily do this doesn't seem like something that you should have to do. Like EF should be able to do this fairly simple thing without you pulling in Dapper to do it. Okay. Let's come back to Cloud Native after we've quickly gone through some of the other stuff, because this is where Shai's got a really cool demo that we definitely need to get to.
Yeah.
So performance, we always do work on performance. I'm sure we will do some stuff that is not related to our main thing here, which is Woodside. I know Shay also, we already have NPG SQL stuff that we haven't yet pushed to Tech Empower, which should help our scores there, for example, that we did at the end of the 7. But for EF Core 8, we are really Shay has committed, in fact insisted that he get to do some stuff on Woodstar. What is Woodstar? So Woodstar is the idea that we will create a modern driver for SQL Server and or Azure SQL. I think Azure SQL is the main focus for this. It may work with both. By modern, I mean using modern .NET technologies for performance and modern programming patterns and ideas around the way connections are managed and pooled and things like that, in order to make this really be a high performance driver. It is not going to replace Microsoft Data SQL Client, because Microsoft Data SQL Client supports a lot of things from lots of versions of SQL Server, some of them very esoteric, but that have customers still using them in here, there, and everywhere. The idea is not to do all of those things, but to make this something that if you're writing a greenfield modern web application, or indeed if you have any application that is not doing anything super weird with SQL Server or Azure SQL, then you'll be able to use this and get higher performance out of it. So that's kind of the idea around that. We've had this idea being kicked around for a few years now, and we failed to really kind of deliver anything as yet. So now Shay is on the hook to actually deliver something. Our initial goal is to try and get Tech Empower Fortunes benchmark running end-to-end on this. That doesn't mean we'll necessarily publish the results of how fast it is, because that involves getting permission from SQL Server org to do that. But functionally, that's what we want to do. That being said, we're also looking at services that are run inside Microsoft by other parts of the company. And if we manage to partner with somebody there that's doing something, then we may switch our focus from just doing Tech Empower, which is somewhat artificial, to saying what we really want to do is get Service X that's currently using Microsoft Data SQL Client to be running end-to-end for these scenarios using Woodstar, because that actually allows us to have a more tangible, real-world use case. So I don't know if you want to say anything else on that, Shay?
Sure. So as Arthur said, one driving force here is obviously performance, because SQL Client is a very old driver. It's been around for a very long time. It's accumulated lots of let's say legacy and debt. Let's call it that way. And as we all know, very old projects are sometimes difficult to bring forward. That's a very, very big thing. In addition to performance, there are some fundamental issues in SQL Client that are hard to fix without like a substantial redesign. So I'm talking about bugs and severe performance issues and on the edges and things like this. And we think that like one way to look into this is to try a greenfield basically thing. Now it's very important to say we're not delivering an 8.0. We're not delivering like a functional driver that that's supported and by Microsoft and people should be using. Right. This is an experiment at this point. It's more of a prototype or an experiment to show what can be done and what that would look like. And we really hope this is one place where we really hope the community will also get involved. So I hope we'll be doing the initial work to lay down the infrastructure and build something, build a foundation. And then I really hope personally, but we hope also as a team, that others will also get involved and contribute to this thing. And of course, if there's interest and people want this, because of, again, the hopefully a dramatically better perf and the bug fixes compared to its SQL client, we could go and do an EF provider over that as well. Like it could evolve into various places, but we're definitely not committed towards doing any official Microsoft product at this point.
Yeah, absolutely. But we hope to make some good progress in this release, better than we've done in the previous releases.
Exactly.
Okay, so Visual Studio tooling. Bryce is going to go off and work with some VS teams on some things specifically in VS. Bryce did the T4 templates in EF7, which allow you to customize what happens when you reverse engineer your database for your model from an existing database, scaffold. And these two things are kind of related to that, but making the experience better in VS. So firstly, editing T4 templates in VS and doing other things with them is currently not that great an experience. And T4 is pretty much a nightmare if you don't have decent kind of colorization at least. So Bryce is going to try and make that better, which could also be advantageous for other things that might use T4 in VS as well. And then also we want to add a database first workflow in Visual Studio. So Eric EJ's Power Tools, EF Core Power Tools already have this. We've talked to Eric, so he's fully aware and supportive of us doing this. We're not, treading on his feet or whatever. But there's a certain class of customer who install Visual Studio and they really expect to just have things work there without going installing additional extensions and things like that. We want to capture those people and lead them down a path where if they've got an existing database, they will use EF Core with it. And so we want to create kind of a wizard similar to what's in there right now from a long time ago. You can do add new ADO.NET entity data model, and that will dump you out in EF6 at the end of it. We don't want people to be doing that because that's what's in Visual Studio. So we want to add a similar kind of wizard experience for EF Core. Not a designer. We don't intend to do a designer. This isn't about doing a designer. This is about you basically having a visual experience out of the box over our existing kind of scaffolding experience that we have. Doesn't mean we can't add other features and other functionality in Visual Studio, but we don't have any intention of doing a full designer in Visual Studio. Okay. And then finally, before we go back to AOT and see Shay's cool demo, there's this theme developer experience, which is kind of basically lots of little things that we could do. So these are there's things that we're considering. So we have this label. So let me go and look at, for example, performance. Okay, I don't know how many is in here. So with 22 items that are labeled with area perf and have consider for current release. We're not committing to doing these. There's a lot of stuff in here. These are things that we potentially could work on that are perf related in EF8, and we're going to try and bring them in based on feedback and doing some other investigation and seeing what makes sense. We'll also look at votes. So this one has a lot of votes, and I know Shay would like to do this, and we have ideas of how to implement this. We've been talking about this recently. So, vote for it. It makes sense. Whether we actually do it or not will also depend on resources. Unfortunately, we've Smith has gone off to work on some VS Code stuff. So we're down to 4 engineers and then me and Jorchen on the team right now. And there's a lot of other stuff that you've seen on the schedule as well. So we don't necessarily can do a lot of these things, which is why we're not committing to a lot of them. but there's a lot of different areas here, and so if there's something that you particularly want, definitely go vote for it. And we do look at the votes. They're not the sole deciding factor. We do this because it depends on resources and a lot of other factors. There's a document that kind of talks about that in our docs, the planning process. But vote for things, and then hopefully we'll get as many of these kind of high value but smaller things done as we can. And with that, let's go back to AOT and talk about that a little bit.
Okay.
So, should I give a kind of? Or do you want to just talk?
Up to you. I can talk to this, or you, whatever you want.
I'll give a quick overview, and then you can go into like showing what you've actually done. Okay, so so what do we mean here by AOT and trimming? So typically .NET has always run with what's known as a just-in-time compiler. And what this means is that when you use code for a first time that's been compiled into IL, the intermediate language, which is basically the same as, same concept as Java's bytecode, for example, once it's been compiled into that by the compiler, that's not in the native machine code for the machine that you're running on. That's in this intermediate language. It's a kind of like abstract assembly language, abstract machine code, if you like. And then you have this thing called a just-in-time compiler, a JIT compiler. And as you're running your application, it says, oh, you're going to use that class, that method, whatever granularity it has. I will take that, I will compile it into the machine code for the machine that you're running on, so x86 or whatever it is, ARM, and now run that code. Ahead of time compilation, instead of leaving it to be compiled just in time, says before you even run the application, basically when you're building the application, take that intermediate language and compile it into the actual machine code that is going to run on your target architecture right there and then. And so this has an advantage, especially around startup time and to some degree performance, because the jitter takes time to compile things the first time you use. So when you first start your application and it's running all this code first time, it's got to compile all that before it can run it. If you AOT ahead of time compile it, then it doesn't take a lot of time. It just loads the machine code right away and just starts running it immediately. And there's other trade-offs and things there, but that's the basic idea. This is a powerful thing, but it's problematic in a language that allows very dynamic things to happen. And this is kind of where EF is interesting, because EF does a lot of things that involve reflection into your code and looking at your model and then determining, what the shape of these things are, and then maybe creating your classes, by using make generic type, for example, to create a class, and then using that to put in an expression tree, and then compiling that expression tree into IL, and then the jitter compiles that in, and all of this is happening when your application's running. It's very powerful and it works very well in a lot of cases, but it makes it difficult to now go and say, oh, we want to compile all that ahead of time, because you don't know what all of that is until the thing's running, right? So Shay has been doing some prototyping on things that we can do that allow us to move the information that we need outside of it's just in the running application, and then do all of that processing before the application runs. It's very analogous to compiled models, where normally when you run an EF application, we build the model for you dynamically before it starts, and you use it. In a compiled model, you run the .NET .NET EFDB context optimize on the model. It takes that model and puts C# code into your project that then has the model already, so we don't have to dynamically build it. And this is the idea, is to do more stuff like that. And this is what Shay has been prototyping, and I think he's going to demo some of how that works now. Right.
So before I jump into the actual demo, just to recap, like what Arthur said, this is about two things. It's about making applications start fast, because in many cases they start too slow. We want to make your application start fast. That's number one. And number two is reducing the size of your application. That's more the trimming component that you see there. This is because, for example, if you want to run an application on your mobile device or on a website, big downloads, like big binaries which you download, that's prohibitively that's impossible. You can't expect users to sit there while you're downloading megabytes and megabytes over the network. It's not easy to take something like .NET, which was really designed with, the traditional server environment, and suddenly to turn it into a thing that can start up very quickly. As Arthur said, there's the JIT and all that kind of stuff. And also that's very, very small and nimble. So we're trying to remake, .NET in a certain way. Now, .NET 7, which was just released, officially came out with the thing called native AOT. Native AOT is one of the main ways to do AOT in .NET. There's other ways in Mono. There's when you're doing MAUI, then you're maybe using a different form of AOT. Anyway, so what we're talking about here is an attempt to make EF Core fit into this model as well. So again, making your EF Core applications start faster and potentially be far smaller, making them more relevant for places like mobile devices, Blazor WASM applications, and possibly places like serverless computing in the cloud. If you're using something like Azure Functions, you want your application to start up really quickly because it has to start up on demand when a user actually hits your API endpoint, right? So this is the whole point here. Okay, I'm going to jump into the code finally. That's the, we can finally go in after all this introduction. So what I'm going to do now, I'm going to let me, I'll make us disappear. We'll just talk about the code. We don't need to see your faces, right? I'll bring us back when it's relevant. So what I have here is a super simple application. Let me put the files here because it's going to be relevant for a bit. So we've got the most minimal model you can think of. There's a blog here. There's a required property, by the way, which works really nicely with non-nullable references, but that's beside the point. I really like this. And then we have a database, which I've already created. We instantiate a blog context, and then we do a very simple query. And what we're going to do is we're going to take the blogs, we're going to get the blog whose name is 1, and we're going to project out that name with single, which is, again, us saying that there's only one, and then we're going to write the name of that thing. So nothing very interesting about this. I will say one thing. This is simple logging, right? This is the way to configure EF's logging. And what I've done here is I've used this feature that allows us to say which logging events we're actually interested in. So I've done 2 logging events here. We're interested in 2 things. I don't want the whole thing to log all the time. I want us to concentrate on specific things. So one event, which we're going to see in a second, is called query compilation starting. In 2 seconds, I'll explain what this means. And the other one is a much more well-known one, which is command executed. So every time we execute something against the database, this is the event that you're going to see. So let me run that program as it is right now. Again, nothing new here at this point. Really nothing to write home about. Let's look at the output here. We're running this. Let's hope I don't have like a big demo crash at some point here, as always. Okay, so I promised 2 events, and here we have 2 events. The first event that we have is query compilation starting. So here at this point, what you see is EF is telling you, oh, I have a query, a link query, and I'm going to compile it for you. And then 800 milliseconds later, that's quite a long time, we have the execution of that command. And here you see the SQL actually getting executed against the database. So a word of introduction, just so people are aware. Actually taking your link query every time, here, let me even put our faces back here so we can see as I talk. If we want to, taking a link query and transforming it to SQL is a big and complicated story. What happens under the hood, what we call the query pipeline, is the most complex piece of machinery inside EF Core. It's very, very complicated. If we had to do this every time you run a link query, your queries would be extremely slow. Database performance would be very, very bad. So we don't do it. We've never done it. It's just, it's completely, it doesn't make any sense. What we have, whenever there's a perf problem, then the answer to that is caching, obviously, always. So what we do, whenever we get a new link query coming into the EF Core query pipeline, we check a cache and we see, have we seen that shape, that tree of, the expression tree, whatever? Have we seen a link query that is basically this one? Have we already seen it and compiled it? If we haven't, then we go through that big thing which you just saw, the thing that took 800 milliseconds, and then at the end we're gonna cache the results of that thing. The next time we run the query, we see that we've already cached it, so we can skip that whole thing. And this is why EF Core can be very, very fast. So we've already made it extremely fast for that case. But when your program starts up, you still have to go through the phase of compiling all your queries. That's part of the EF startup experience, or the slowdown of EF. When you're first starting your EF application, your cache is empty, so you have to go through the compilation of all of these queries, right? So what I'm going to do now is we're going to attempt to make that go faster. Again, make EF go faster. Now, another piece of information for you is, so one thing is about generating the SQL, right? I mean, that we compile a query, the link query, we transform it to SQL, we send that SQL to the database. You can even see it here. But there's another thing that we do in the query pipeline. We also generate dynamically a piece of code, this is a bit of internals, that will know to read the results coming back from the database and hydrate or materialize those results as your entity type. Right? So usually EF will load blogs for you, right? So when we get the database results, we want to have an already ready piece of code that knows to take those database results and bam, create blogs out of them in the most efficient way possible. So we do runtime code generation in order to do this. And that, again, preparing that thing is a complicated process. It's long. And it is also not very compatible with the whole native AOT approach that we're going to. Because in the native AOT world, when you're trying to do all your code generation in AOT, so before the application runs, that means you can no longer really generate code with a JIT. There is no more JIT when your application runs, right? This for people who know .NET, this should be mind-blowing because it's a completely different way of thinking about .NET. EF does runtime code generation to create that materializer. We will no longer be able to do that in the native AOT world, right? So we need another solution in order, to get around this. And now I'm going to go back to my demo and I'm going to do something cool. I'm going to open a terminal here. And what I'm going to do is I'm going to run a command. Now, I've hacked things up. This is a prototype. This is not anything remotely resembling, code that anybody should run. And I've hacked this command. This command usually does something else. That's the thing that currently builds the compiled model. But I've hacked it so that it does my thing instead, just, for the purpose of this demo. So I'm going to run this thing. I'm not going to explain what it does. I'm just going to show you what happens. And then I'm going to maybe explain very, very quickly. Because, again, this is just an EF. This is just a
teaser.
It's
trailer.
a teaser, exactly. I'm not going to go into all the details. So it takes a lot of time to build because it has to rebuild everything.
And you're also running StreamYard at the same time, which is taking up your power.
Yeah, that's actually.
I hope you shut down Teams.
That's actually a big thing. This one faster in my. I have not, in fact. Let me do that right now. That's a good suggestion. Okay, it is running. It's just a little bit slow, but it is running. That's very encouraging. I thought I would have a demo moment here. All right. So this thing finished. It says something about query pre-compilation complete, processed 1 queries. So I'm going to jump directly to what happened. So in our project here, this is like my normal project. I suddenly have this new file with an ugly name. We don't care. This is all just a prototype. I'm going to quickly click inside just to show you what it looks like, but we're not going to actually analyze it. So there's this thing that got dropped into your project, basically. And again, we don't really care what's going on here. It's all prototype grade stuff, but it does something. And the important thing is that now what I'm going to do is I'm going to rebuild my own project here. That's, again, going to take some time. Come on. I should get a new laptop.
You were just saying you needed a new
compilation
machine.
At the same time. That's actually my real machine, like where I work, is a Linux machine because I'm a Linux guy. And doing stuff like Teams and StreamYard from Linux is something that I don't really dare. So okay, we rebuilt our project, and now I'm going to run it again. And let's see what happens. Okay, first of all, we have this message here, which is just for debugging. But the important thing here is that we now only have one event. So the first event, the compilation event, is gone. So spoiler, like the spoiler alert now, what happened here is basically that our new experimental thing generated this thing, which precedes, it basically moved the whole compilation process, which is long. And again, that's the thing that takes time at startup. We moved that whole thing to design time. So when I ran that command, what this did is it actually looked at my source code, at the user source code. It located link queries inside, stuff that looks like link queries inside that source code in static analysis, and it passed it through the EF core query pipeline at that point. And the result of that thing, which is the materializer, the code-generated thing, we took it and we actually generated it as C# code. And that's the magic here that you see here. Now, this is a very, very small query, but here you actually see C# code that goes to the reader and gets the string at index 0. Now, I'm reminding you guys that in our actual application, we are simply projecting a single name. So we're just loading one thing from the database, which is exactly what you're seeing here. This is the piece of code that's going to read back the thing from the database and return it to you. Of course, so, if you start projecting, don't worry, I'll leave a lot of space for questions. If you project out a blog instead of a string, you're going to see something very, very different here. You're going to have to see code that interacts with the change tracker and all kinds of complicated stuff. But I deliberately want to do something simple so that we see everything. So just to summarize, this is something that statically analyzes your program, locates link queries, does all the necessary long stuff at that point, and just spits out whatever it is that you need so that when you actually run your application in production, all those resources are already there available. And we think the way we think this can be used is you can have a step, for example, in your CI build, which does all this stuff, so that when you're working normally, like in your inner loop and as a developer, things run normally as you're used to. But to make your actual end application start up much faster and take a lot less space, you would have maybe a step in your CI or something similar at some point, which will very significantly optimize how it works.
Okay. Yes. So there aren't actually a lot of questions, but I think maybe people either they've just left or they don't realize how amazingly cool this is. And I want to point out something that perhaps it's because I've spent a lot of time working on this code and everything, but I think is super cool. What you're seeing here, what's on the screen, this executor, that is what EF executes normally when you write a normal query, except it generates that as dynamic code, and then it compiles that code into IL that then a jitter then compiles. But that's what we do. That's what EF does. That's EF's prime function, in a sense, is to take your link query, to take your database model, to take your database provider, to connect them all together so that you can have a piece of code that executes that will, as efficiently as possible, get the value that you want and stick it out into the result. Or like Shay, this is projecting a single string value, but it could also be setting that string value directly into the entity instance, for example, or
exactly
data reader get string being called directly into your constructor of your entity if you're using a structure. So this is what EF does. It generates this dynamic code and compiles it. And so what you're seeing here is almost like magical, to me at least, because it's like taken that stuff that's like this dynamic thing that you never see, but which we strive to make as efficient as possible, pulled it out and is now compiling it as actual C# code. And I think this really kind of, I think it actually on a almost philosophical level shows what an ORM can do, because an ORM does not have to be all of this code that says, oh, find what this property name is and then read that by reflection and then go and access the database in some general way to pull this value back and then go and find out where that is and look that up and put that in there. Because we've got all that information, the ideal thing that an ORM to do, it says it knows that it's at position 0 in the data reader. Just give me the thing at position 0. I know that is because I've compiled all that in. I know that it's a string value, so call get string. There's no, in this case it's a reference type because it's a string. But if this were a value type, we wouldn't need to box it. If it was an integer, we just get the integer. We don't need to box it in any way. We don't need to do any conversions. And this is really what an ORM does dynamically for you. And it's very cool to see this actually in code, so you can kind of get an idea of what's actually happening. And of course, this is an extremely simple example of what the materializer can do. If you imagine when it's pulling back, a query with includes that's bringing related entities, and it's create instance of those, and then populating references onto other things and all that other stuff. It gets a lot more complex, but essentially, it's all the same thing. It's very efficiently get stuff off the data reader and put it into your results.
Exactly. Now, it's also important to say we're also not committed to delivering this or native AOT, native AOT compatibility. So first of all, actually making EF compatible with native AOT is larger than this thing, and it might be blocked on something else. So this is part of that story, but it's like taking a huge ship that's going in one direction and turning it around. It's a big endeavor what we're discussing here, because EF has been designed in a certain way, and .NET has been designed a certain way, and now we're trying to make it go in a different direction. So I do hope, I actually am pretty optimistic that we can deliver something for EF Core 8, but we're not committed to it because we don't yet know where the pitfalls are going to be.
Yeah.
This is quite experimental at this point, but it has
a lot of learning.
There's a lot of learning for all of us inside, me as an engineer working on EF Core. This is a new thing. I have to learn a lot as well. It's a new way to reason about, how to do things. But it is extremely exciting, and it opens up, especially perf-wise, it opens up some possibilities to make EF, dramatically faster even than it already is, and it already is very, very fast. So at the end of the day, when you run a link query, it could be as simple, like in the best of possible worlds, it would be an extremely light thing that has already been code generated for you, like you saw here, and everything just executes immediately, and you get your results, which is not the way things work today. Today there's quite a bit of overhead that has to happen, so we're working to make that better for everybody, basically.
Good stuff. There's a question here that I think is one that everybody always asks. How do you know that it's our iQueryable and not somebody else's iQueryable?
Right. So the short answer is this. So what this does is, first of all, it analyzes your code, your source code, statically via Roslyn, which is the compiler for C#, right? So it's very similar to a source generator or an analyzer, in the sense that it uses Roslyn APIs to analyze code. It is not a source generator. As you saw, I ran a command to make it work, and there's a story behind that as well, but we're not going to go into it. How exactly are the queries identified? So one limitation, which we already know will be there at the beginning, at the very least, is that this is only going to support what's called non-dynamic queries. So a query, in order for this to work, the query has to be there in its entirety from the DB set all the way to the terminating operator, which in this case was a single, right? Or a to list or something of the sort. So the whole query has to be there. If you have a dynamic query scenario where you're creating, you have a DB set here and you're composing some operators there, and then you're evaluating it over there, there's absolutely no way anybody can look at your source code and understand what's going on there, right? So in a way, this is an AOT thing. In order for AOT to work, there cannot be any sort of dynamic generation happening. And this is true just as much at the .NET layer. You can't do runtime code generation because you have no JIT. It's true at that level, and it's also true at the EF Core level, right? You cannot dynamically compose your queries either, because that goes against the principle of AOT, right? So there's going to be limitations here. Not everything that you can do today with EF Core you will be able to do in this world, but of course you don't have to use this. So nobody is forcing you. EF Core will continue running exactly as it is today, and everybody's code continues to run. But if you want to take advantage of this feature, then there are going to be some limitations, and you have to have your entire query analyzable as a single chain of link operators based on a DB set on your context. Basically, that is the requirement, and that is how it is analyzed at static time.
There's an interesting question here that I haven't actually asked you about, Shay, but now I'm kind of interested in what the answer is. I'm trying to find it again now. Oh, here it is. So this is dependent on knowing the database provider. Is that true?
Yeah, that's correct. So especially the SQL is very dependent on the database, but also the materializer is, at least in theory, dependent on which database you're targeting, right? Because different databases might have different, tweaks in the materializer. I'm not sure we have that actually today that much, but a little bit for sure. Yeah, absolutely, we do. In general, there's also a feature in EF Core where you can have multiple models, and that is also incompatible with this. So this is another, if you have multiple models, then that is incompatible. If you want to target multiple databases, that is probably going to be doable by doing this process twice, right?
Mm-hmm.
There's probably going to be a way of saying, okay, precompile everything for this and precompile everything for that. Although I'm not yet sure how all this is going to fit together yet. So there's really a lot of question marks and a lot of challenges around this. Right now, I'm focusing very much on the simple case with one targeted database, one model, and just getting everything working. That's enough of a challenge for sure. But multi-database is definitely something that we need to keep in mind, obviously.
I think a lot of the learning that we have to do and a lot of the experimenting we have to do is figuring out what these limitations are, whether there are ways to actually work around the limitations or not, the cost of doing so, the value, because the idea is that we want this to feel like using EF Core. We don't want it to be a new thing where it does, I mean, we have ideas around, things that could be new and also AOT compatible, but the idea here is to take existing EF Core experiences and for a large part make them work in an AOT mode. And so we really don't want to take away stuff. At the same time, we don't want to compromise the value that you get out of doing AOT by trying to make everything work and therefore ending up with something that really doesn't do one thing or the other. So it's kind of it's a balancing act that we're kind of trying to do to figure out the right thing. And we're working with, David Fowler and Damien Edwards and various other people on, understanding that at a higher level. Erica and Hart is doing stuff in .NET. Jan, I forget his last name. Kotash is doing stuff, so this is across a lot of teams trying to, figure out where the experience lands,
exactly.
But it's exciting stuff that hopefully will get us to a place where you can have an ASP.NET Core and EF experience that works in an AOT world, even if it doesn't support every nuance that you can currently do with those technologies.
Exactly. We hope to be able to give you build time warnings where there's a problem, let's say, or something of the sort. Or at least very clear failures when you're doing something that's incompatible with this new world, and then it's up to you. Either you change your code to adapt, or you can also decide not to use AOT if that's too much work for you, and that's completely fine.
And I think there'll also be places things that we discover. This is already happening. Things that we discover from doing this that end up improving the code that we have and the scenarios that we have, not in a pure AOT world. And so, for example, you might have some dynamic queries in your code, and you might have some very commonly executed, or maybe they run at startup, and so you really care about the startup performance of these, and you can use this kind of mechanism that Shay is showing, without going on the whole full, I'm actually now going to AOT my entire application in terms of like, not having the jitter or any dynamic code generation. So that kind of hybrid between the two, I think, is also going to be interesting to see where that comes out. So yeah, very much a lot of learning and understanding. And Andrew's going to be working on this too, looking at some more of the kind of model building and change tracking side of it. So yeah, good stuff. I'm super excited.
So am I.
Okay, I think that's. I think we've basically got to the end. We've run over by 20 minutes, so not almost 2 hours like our EF7 like whirlwind tour one, but still,
It's an
longer.
improvement.
Yeah, we're getting better at sticking to the time. Yeah, not much, but a little bit. Okay, so we're going to come back in January with I think Jorchen and I have been talking about working on what is entity framework or something like that, like a very intro, like let's, help people understand some of the basics here, because some of this stuff gets pretty complicated.
Absolutely. The dummy's guide. I'll be the dummy and we can make our way through.
Okay. So, yeah, thanks everybody for being with us this year and, supporting us and being a great community. And thanks to the team for all their great work. And we'll see you next year with more of this stuff.
Happy holidays, everybody.
Bye, everyone.